So last episode, we actually fixed a hard problem. The PostgreSQL max connections limit was capping us at 100 virtual users. We increased that, and boom, suddenly we could handle 600 users. But that got me thinking. That was one hard bottleneck we found. What are all other ideas, tricks, and quick wins that could push us toward the actual maximum throughput of the system? And look, we didn't get here by accident. We have built the entire ecosystem to make this possible. We are using K6 for performance testing. We have all the metrics and logs and everything else from Grafana and Prometheus. We have also infrastructure set up and it's running on Kubernetes. So now the question is, what optimizations can we actually implement and measure? That's where today comes in, mapping out those 26 different performance optimizations ideas. Everything from 5 minutes quick wins to architectural changes that could fundamentally shift our throughput. And I want to be upfront about some. I didn't come up with all these ideas on my own. And I don't know everything here. I use the OpenAI Codex and also Perplexity to challenge my thinking and ideas. Get back suggestions I wouldn't have considered. Then I validated everything against our actual scenario and code. So today, we are walking through all 26 together. Some are quick wins, implements in 5 minutes, and measure the gain. Others are architectural shifts that could literally 10x our throughput. Some I'm confident about from experience. Some I'm genuinely learning as we go. And that's exactly what I wanted to explore with you. Ready? Let's go. Okay, so we had this baseline solution, which had 1800 maximum RPS, which is the baseline of 100%. We had a median RPS 700 RPS and 100 virtual users for reading. And for writing, we had 2800, 495, and 100 virtual users. And we can check that here. That was already presented last time, but to recap this, let's go through again. The pattern for all three is the same. So it's going to the maximum throughput, and then something happens right here. And we already proved that previously we had a cap of 100 maximum connections on the PostgreSQL, and that's why it couldn't make more connections from API to database, and it was saying too many clients, right? So that's why it was dropping to the 600 because it was doing the back pressure. And in the third attempt, as you can see, so C, the third attempt, is already going through without the problem, and it's going up to 600 virtual users. And then we attempted the second one, which is database context pooling enabled, and we changed it to 300. But this didn't help too much. It didn't help at all because we were not solving the problem where it should be solved. And maybe and the third one is the problem which we solved last time, and we raised from 100 pull from 100 to 300 or 400. I don't recall right now. And the max connection budget was increased, and that solved the problem, which you can see already. It's significant boost. It goes from 100 virtual users to 600 virtual users, and from 700-ish to 2000 RPS on median. So 280 almost percent increase from the baseline, right? So here's also a very important calculation information that we are calculating this number out of the baseline number, right? So this is the baseline percent. And also it helped for writing. It went from 2800 for the maximum throughput. It didn't help because we had it at the beginning already very, very high. But when we were adding more parallelism, it was starting to fail. And I expect, and that's proven by data, that it was almost 500% more requests per second on median. So And I also went through with the maximum virtual users, which is 600. And that's a great benefit. And that's why I wanted to outline the plan, which is going to be for the next releases and next performance testing attempts, which we are going to partake. And yeah, let's think about those. So we have a couple of things. As no tracking on catalog read endpoints. Can it help? I think yes. And it can help, will not track the changes of the query. And it entity framework, which we are calling to database through, and we are using this, I believe it might have some influence when we will just turn it off explicitly. So entity framework will already know that we don't need to track the changes because we just want to read it. We don't want to leave the door behind just to modify the entity by some updates, anything like that, right? So I believe that this might be really helpful, and maybe just put it as very good to be included in the next deploy. And I think this is API only, and this is useful. I don't know how many percent is going to be, but I think the best is going to be that I will batch a couple of these changes, and we will check what is the actual performance gain. Another one, response compression enable gzip or broadly to shrink payloads on list read endpoints. I believe it should help because every time we are calling the API is, of course, giving us back the response, which should be compression, and JSON shouldn't have any kind of spaces, anything like that, any white spaces. So probably can help. I don't know if in our case it will help, but worth to try. I believe this is only changed on the API level. So I believe this should be as a third one. Cancellation tokens on async calls. Cancellation tokens pass the HTTP context request aborted, so aborted requests, free threads, and DB work. Because in our case, when we are calling the APIs, we do not, let's say, cancel our connections. And also, when we reach the saturation, and these requests should be canceled when the user shouldn't wait. But in our case, we are stressing this API. So I'm not sure if this is going to help, but it's worth to try. Yeah, worth to try. And what else? Another one. NPG SQL, command timeout, and transit retries enable retry on failures. It's similar to previous one, which is, let's say, we expect that every single one will actually be successful and not failure. But yeah, probably when there's a failure mode or one single call might actually fail during, let's say, millions of requests that will send, maybe this one actually will help because one request will be not hanging around and will just fail to the user and will free, let's say, the queue. Yeah, worth to try. That's my analysis. I'm not sure. Also, this entire list, I'm not, let's say, fully familiar with all the tips and changes, right? So this is also great learning for me because I think we all learn here, and this is a good challenge. Global node tracking default in database connection context options. Global node tracking default. Use query tracking behavior. So reads are no track by default, opt-in tracking for writes. I think I will skip this because this one is exactly like this one. We will be doing this explicitly and not this. So I will just maybe hide it. Enforce pagination max page size. Enforce pagination clamp page size to avoid accidental full table scans over HTTP. I need to check this. I'll check this after that. I think that already contains pagination, but definitely if that is the case, worth to have the pagination because we don't want to retrieve 1 million rows, right? We want only, let's say, 20 or 50. depending on the default. But maybe let's stop here. This is the plan, I think, with the easy ones, which is going to be a great next attempt. So we'll have a controlled release and not have 20 different changes, because I also want to have a little control and this atomicity. So I will know more or less that, let's say, these five changes helped and not like 20, right? But also on differently, I don't want to do every single one row attempt by attempt, because every single one takes like 10 minutes just to run the tests. But for me to go the entire cycle, it's like, I don't know, 1 hour or something like that, because I need to process the data, analyze that, and so on. I think I want to batch this and select this as a one release, as we should go only higher and higher in this case. Okay, so that was the easy batch. At least this is what Codex said to me, right? Okay, and let's see what will be for medium. Project only columns, DTOs for list endpoints. Okay, and more context. For project only columns, DTOs, select only needed fields before to list async to reduce IO and serialization. Yes. I think it's very important to understand what actual data the user needs. So an example is, if the user only is interested in one particular field or particular set of data, there's no need to send him the entire list with all the columns, right? So this is all about when you have a select on when you have a select on database or select on API level, it's worth to operate only on data which you actually need, because then everything is of course transferred, and it takes time and process time and also memory. Keep it inside the computer or server. Just remove what you don't need. Hot path fakes. To think about this, because it's actually tricky. In our case, I want to have the same probably amount of data to compare to. So for the baseline, so I don't want to synthetically shorten amount of data, because of course it will be faster if I will send half the data, right? So I probably will skip that, but it's good learning to always remember about this. Okay. Hot path indexes name brand type. Ensure indexes support the most common filters and sorts. Yes, and this is one of the things I will. I think that is the bringing the most by my experience. If this is unchecked or you have some legacy system, you actually want to take a look on this, because sometimes certain queries, certain processes can be very easily boosted and improved by just added one index on something that you are actually requesting, right? So it can be a situation that at first it doesn't really impact your system, because on your system you have very little data. But when it grows, and let's say a month later, a year later, the data just grows and grows, and it turns out that certain searches which was working super fast at first, now they are very, very slow, and it can bring up to, I don't know, like 100%, 1000%. It can go from 5 minutes query to 2 seconds query, because if it's properly indexed in the database. So definitely I will record a video about it to just check if we have everything in order. Probably we have everything in order, but it's very good and super important to check this kind of data. And these kind of data can be checked inside things like the dbeaver, or any kind of solution which is helping you and giving you insight into the indexes. So in our case, it's going to be PostgreSQL. So dbeaver would be great. But if you have things like Azure SQL Server or SQL Server, it has their own tools to do that. Yeah, so on SQL Server, you can use um, its own insight from the SQL Server Management Studio. Okay, another one. Avoid n+1 via projection instead of broad includes. Avoid n+1, use projection or includes wisely so queries fetches needed related data in one round trip. I'm not sure if that's gonna be real problem inside of the when we are using Entity Framework and .NET and in current setup, right? So let me return to that. But I will definitely put it onto the list. Lean serialization settings. System text JSON. Lean serialization. Keep system text JSON defaults. Avoid heavy converters to reduce CPU. So inside .NET, we have two main serializators, which is Newtonsoft and system text JSON, which was lately added to the .NET. And we can also play with that. Plus, it also mentions about heavy converters to reduce CPU. Maybe one or the other could be better for our instance. Maybe Newtonsoft is better. Maybe this system text JSON is better. I will need to find out. And this is for on API level, from what I know. And so far, I will need to think about what is going to be the batch. And it's early validation. So what do we have here? Request payload size limits early validation. So we should reject oversights or malformed bodies early to protect resources. In our case, probably not a problem because we do not care about, let's say, big chunks of data or something like that. Maybe in the future, but that's not the case. I want to get maximum RPS with all the tricks that we can get. All right, so let me hide it, this project only for list endpoints, because we already have this avoid n+1, and I think this means almost the same. So we have this clarity. I hide it in outbox patterns with single safe changes. I think it's what it means. It's about batching the multiple requests at once and only for writing path. And when we have multiple catalogs items, then at once we should save the changes. But in our case, we 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 can do this, of course, with some tricks. But what it means in here, I think it would more relate if we had a transaction of multiple items inside multiple logical items, logical transactions inside a, let's say, outer transaction, and which would do something which is irrevertible. So for instance, we have to do three things. We would save the log internally, and when everything is done, then locally we would store it to the database. But in our case, maybe it's something different. I think I need to recollect on that. I'm not 100% what it means. I think it's worth to investigate it and to understand it. And I think this is API and database change. So it might be medium/hard. Trim, adjust indexes on heavy write tables, reduce contention. And remove non-essential indexes on hot write tables to reduce insert and update cost. I believe we do not really care about the cost of the money, but we care about cost of time. So non-essential indexes, yeah, exactly. So when we write, every single index costs us time because whenever we are inserting new item, the database needs to refresh the indexes. It needs to calculate the index. So that will be our cost. I don't think it's hard. I think it's medium. And I would change this. I would change this and this. Both of them. So connection budgeting per pod pool should be less or equal max connection and replicas. So it already is speaking about replicas, and I think that we should put it hire this. So we should speak first about read replicas for logical streaming to offload reads and up routing. Read replicas, offload read to replicas, route write to primary. So what it means that we should have multiple instances of reading, and we can only write to one instance of database to write. Read replicas is, I think, great, and it's going to be our one of the biggest points, I think, in the series. And I'm really thrilled and I'm really excited to do this. I can't wait to do this, actually. We can have, let's say, 10 replicas, so 10 instances of the database, which we can read from. And if you have read-heavy system, we can go to with the read replicas, right? The great example is Netflix. And let's simplify that a lot of people are actually reading only. So a lot of people are watching movies, but there are not a lot of changes during the day. And they're not adding every day, let's say, 1,000 movies, right? They are adding maybe a few, I think. Maybe I'm mistaken. But generally, they are read heavy. So we are reading we are calling read replicas, so that it can serve many users at once, but only one is only the master. So all of the replicas are actually retrieving data from the main node. And I think it's going to be really great piece of work, and that's going to be 100% different episode. And what it does, I think it needs to be API database, right? Connection budgeting. So we need to ensure that total possible connections across the pods stay within Postgres max. Connection budgeting per pod pool should be less or equal than max connection replicas. So we need to ensure that possible connections across pods stay within Postgres max. So it means when we'll have 2 APIs or 3 APIs, and we'll have, let's say, one Postgres, we should go no higher than maximum of the PostgreSQL maximum connections, right? Okay, and I believe this is only database change. And with this of read replicas, might be possible that I will, or maybe separately, I will record something about PG Bouncer. Is a pooling system which will help us with the database connections. And let's talk about it later on. And NoSQL read model, Elastic Mongo for denormalized views, CDC ETL. I don't know what's CDC ETL. And denormalized read store for fast queries, and Postgres remains source of truth. I don't know about this, but I had something different on my mind, because what I think is true, it's that Elasticsearch or MongoDB are NoSQL database. They are scaling better horizontally than relation database. So I maybe will copy this and hide first one, and I will go with the NoSQL transition. So it might be MongoDB, or yeah, let's say, or other. Yeah, and the previous one, I'm not sure. I will need to think about it, what actually it means. Maybe it has a lot of sense. So if you know more, please let me know. I am not familiar with that and how it would work. We would need to split the application into two: catalog API reader and catalog API writer. And then it would mean that we have two different instances. One is reading, one is writing. So already, if we would need to scale horizontally, we can just, let's say, scale only reading. So more API readers would appear and not the entire instance. So it's very much connected with the scaling, which we will do in the future. And let's say totally different than read replicas. So I think, I'm not sure if it's here. Here, I think it's very much connected to each other. So I'll put it first actually. And auto scaling, yeah. HPA on CPU RPS plus PG bouncer pool, DB scaling via replicas. Okay. Yeah. So what it means is that we will replicate our API and we will replicate our database. We'll have multiple replicas and we'll need to configure all of that. So we'll have, say, 3 APIs and 2, let's say, databases. But I mean, 1 main database and 1 read replicas, or 5 read replicas. And we'll play around that and we'll see where is the bottleneck next. And so this CQRS split, we can go easy with that. So splitting our system into 2 for queries for reading and commands for writing, and all of our system is either it's reading or this is modifying or in creating the data, so it's command. And when we go further with that, we can actually create the EDA, so it's called event-driven architecture, and also have additional mechanism connected with the CQRS. But I think it's very, very wide topic, and I'm not the best person to speak about it. But in principle, I get the point, right? So CQRS split, it's already, I think, API and database change. Auto scaling is API and database change. NoSQL transition, I think I will need to put it lower because I like it less. Yeah, let me put it. Partitioning, sharding in Postgres, and split large tables by tenant range to reduce contention and bloat. Okay, I think it's gonna be a little bit more complicated, and I think we'll play with this after or during the auto scaling around here. So let's put it here. And it's going to be in only database change. I'll put it like that. And materialize views or summary tables for hot aggregates. Pre-compute hot aggregate refresh periodically. Yeah. Okay, so this is about SQL. And this means that if we used some view from database, and this could be useful when we used view, and view could already preload certain things and faster that ad hoc queries from database. So I think it's pretty simple when it comes to include it, but I think I will leave it at the last resort. I don't think it's hard. I think it's medium, but I will leave it like as it is. And I will put it as a DB. Actually, it's also API change because we need to change how we connect to the database. VAL level, CDC to queue, Kafka Rabbit, fitting read stores search. So VAL, I believe it's write ahead log level CDC. I don't have a clue what's CDC. To queue, fitting read source search. Stream changes to Kafka Rabbit to downstream read search stores. Okay, it makes more sense now. I believe what it means that when we have reading, when we have a writing and inside a event-driven architecture, and we only are sending the events, storing into some separate table, then it could be streamed through the Kafka or Rabbit for downstream read and search stores. So it means that we'll have 2 different databases, which is, so we would have 2 different databases. One is for writes, so it is actually our main database, which we append all the logs. And then we have a second database, which is being streamed and connected between the first database and second database. And second database is actually sending all the time the newest changes and applies those changes on the read database. And it's that way in event-driven architecture, it works. But yeah, it's very, very large topic. And I'm not really sure I explain it the best way, but I think it's worth to mention. Maybe would have some gain here, but I cannot predict it right now. Yeah, maybe let's put it for later. I don't assess it that very well, this idea. Table index tuning, partial indexes on hot predicates, cluster index. So index only hot predicates, cluster on common sort key for better locality. Architecture review and scaling plan finalization. Formal pass to right size pools, replicas, and storage for expected RPS. So this is like the final step, which is going to be just finalization and maybe tweaking the right size pools, how many replicas we should have, and that's going to be, let's say, the last step and just summarization. So that's not going to be any kind of change, nor database nor API. So I think I should leave it blank. Right. So that's how it looks. I think this is 26 points, which I went through. Wow, this is a lot, I think. And that's a lot of things that can be done into 2 endpoints. Of course, will change drastically. The architecture will change drastically. How we work with this will change how many APIs we'll have. Maybe we'll have not one API, but 2 APIs if we introduce, for instance, the CQRS and the split and auto scaling, or maybe just scaling to 2, 5, 10 replicas, right? We can split the database. We can split and shard this database. Well, so from user perspective, nothing changes. Nothing changes at all, and shouldn't change, of course. But internally, inside the system, everything is different. It communicates differently if we introduced all of these changes, and probably it's gonna work much faster. So from something very simple, a very simple reading, a very simple writing, we can get it to the very complicated system, having all of this and paying actually the least, most probably, for infrastructure. Because if the system is performant and it can be sending a lot of data and does not need a lot of resources, it means we'll not pay that much money to cloud provider or to on-site, on-premise servers, right? So the more performant our API is, more performant our entire system is, the better. So in the next episodes, I believe, I will go and choose those easy steps and apply them on our system, and I will see what's the difference. I'll put it here, and we'll be able to see how this system is doing depending on the change we have made, right? If you have any idea, any maybe comment about it, maybe you have different opinions about it, maybe some of them do not make sense, or maybe all of them do, please leave a message to me. I will be very glad. And yeah, see you around. Thank you.